Great. Hello, everyone, and welcome to a webinar hosted by the Cloud Standards Customer Council, Cloud Customer Architecture for IoT. Today, we're going to walk through a reference architecture that illustrates how to support the Internet of Things, or IoT, using cloud computing. And my name is Tracy Berardi. I'm Program Manager of the Cloud Standards Customer Council. I'm serving as your moderator today. And I'm very excited to be joined by Mr. Eric Libo, Distinguished Engineer at IBM, the CTO of Connected Products, the IBM Watson IoT Group, and Mr. Gopal Endurkya, an Executive IT Architect at IBM in the Watson and Cloud Architecture Group. So this talk will introduce the Cloud Customer Architecture for IoT deliverable that was first published by the CSCC in 2016. We'll start the presentation with a brief overview of cloud solution architectures. As you can see on this slide, the Cloud Standards Customer Council has been delivering a whole series of these vendor-neutral cloud architectures. And the papers illustrate how to leverage cloud computing architecture to support technologies like e-commerce and big data and analytics capabilities, IoT, mobile applications, hybrid integration, API management. You can see we have a whole list here that you can view in addition to the paper we're talking about today. So today we'll discuss the IoT architecture in detail and then walk through a real-world example. Gopal will bring us through it. That discusses how smart home data can revolutionize an insurance company. So the cloud solution architectures, moving on to the next slide, they're targeted to developers, architects, and IT managers that are planning to build cloud-based applications. The architectures contain straightforward descriptions of elements that are needed to implement application solutions using cloud infrastructure, cloud platforms, cloud software, and cloud services. The architectures are deployment neutral, meaning you can use public, private, or hybrid cloud environments. And they're implementable using infrastructure, platform, or software as a service. So the papers are really written to help facilitate conversation between cloud customers and vendors. We hope that you'll find these useful in your own projects. I'd like to point your attention to the Attachments and Links tab on BrightTALK. We have gone ahead and uploaded a PDF version of today's presentation deck that you can download and take with you. We also have a link to the IoT reference architecture in its entirety that you can also download and take with you. So now let's jump right in and discuss how to support IoT using cloud architecture. I'm going to turn the presentation over to Eric Gopal, CTO of Connected Products at IBM Watson IoT. Eric, it's over to you. Thank you.
Thank you, Tracy. This is the overall overview of the overall architecture, showing you from a conceptual perspective the different components that are part of an architecture, as well as you'll see the different layers, whether we're talking about a user layer, proximity layer, the public network, the provider cloud, which is typically where you're going to build your solution itself, and the integration back to the customer's own existing solutions, which would be the enterprise network. And I'm going to go into each one of these components in a little more detail and give you a little flavor for things to consider along the way. And you'll notice that there's an awful lot of slides in the PDF, and that's because we couldn't do automation in the PDF. So we're going to do a little bit of change from slide to slide. So if we move on to the next slide, this is basically showing you a little bit of the data flows, and you'll see that they're done here in different colors, so you can follow what kind of a flow is it. Is it a control flow? Is it automation? Those kinds of things. And they're color-coded here on the bottom, on the left. And the arrows flow through the entire diagram, and we keep the color coding all the way through, so it's easy to follow. So moving forward one slide, we can talk about first the IoT user, and this would be the person trying to use the solution itself. This is not necessarily what we're trying to manage. So the user is typically logging into some level of application, whether that be a mobile application, which in a lot of cases there are mobile applications that are associated with these solutions. And in some cases it could be a web, but it can also be both. So we have certain users who will use both a web type application as well as a mobile one. So they're the first person, and they're who we're really aimed at. What kind of value are they going to get out of the solution in using it? Next thing we look at is the end user application. As I mentioned, this is domain specific. It's either done for a specific device in some cases, in a lot of cases I should say. It is done for a mobile phone. But there are certain specialty devices that are used in some of the solutions I've been involved in, different form factors, whether they're using an iPad for this particular application because they need the larger real estate size for the kind of data they want to display, or it could be, like I said, as small as your iPhone, and done quite a few solutions with that. Next thing would be the physical entity, which is what I'm trying to manage, and this could be anything from a home appliance to a small leak sensor in a house, which I think Gopal will talk a little bit about down further. But these can be tiny, just a single sensor, or it could be something as complex as a car, which has thousands of sensors in it. So you think about this as just what I'm trying to gain information about. Next thing I have in here is the actual device itself. So it probably has one or more sensors on it, or hopefully we have actuators, which means we can take some kind of action. It has an agent. It's going to have firmware. And what's important about thinking about solutions here in this space is that it is going to be network connected. It is going to have some level of user interface, and again, that may be through that mobile device. But when you think about a device that's in the field and it's going to have firmware, you're going to need a way to update it. So as you start to develop your solution, you need to think in terms of this is not a device that gets out there and is flashed once with a set of code, but think about either a customer being able to add additional features, maybe having to close security holes as they get exposed, or just having to update it based on things that change around it in its environment, could be the network, etc. So you have to have that involved from day one. Think about, how do I keep this up to date? Next thing look at is an optional component, which is a gateway. And this can be, depending on the application, sometimes your phone is used as a gateway, or it could be a physical device that's an actual gateway. And what they're generally used to do is translate downstream. It talks one level of protocol, so some could be existing devices if we're talking about a factory, for instance, where these things are already talking various specific protocols, or it could be something that is running a like Bluetooth low energy sensor that is talking through your phone as a gateway, for instance. And it's able to do some level of logic down there, so you want to be able to do things like filtering. It does understand and will register the devices upstream. And you can do some basic analytics there, just like I said, things like filtering. Maybe I want to do some level of summarization of data. So if it's talking to a sensor multiple times a second, maybe once a second is good enough to send upstream. So it's those kinds of things that you'd want to be able to do at a gateway level. And these can be anything from as small as, and I'd say your phone is probably pretty powerful, but something as small as a Raspberry Pi on up to industrial-sized gateways that can do quite a bit of processing. And so when you're selecting a gateway device, it is very important to think about all the types of capabilities you want to be able to run down there, especially from an analytics perspective, so that you can pick the appropriate device. You also have to take into consideration the surroundings. So if we're talking about something that's in, let's say, an industrial setting like a factory floor, I can't just put a typical PC-type gateway or network gateway out there. I need something that's a little more ruggedized to withstand the environment. So it's all those things that come into play when thinking about picking a gateway. As we move forward, we have another optional component called a peer cloud. And again, I think Gopal will refer to this in the example solution. But in a lot of cases, you'll find that sensors are already connected to a specific cloud. And a good example of this would be if we are going to talk about the home insurance market, which he will talk to later. A lot of the sensors, manufacturers already have their own cloud applications that collect this data. In which case, if you're going to build an application on top, you may or may not be in the same cloud provider, but you will certainly be in your own cloud, and therefore you'll be doing a cloud-to-cloud communication as opposed to taking those sensors and making them connected to your cloud. You may just be able to flow the data and then perform additional analytics and visualizations in your application. One of the things to think about in the pure cloud scenario is you're going to have to think about, how do I securely move the data up and back? How do I make sure that only the right things do flow? How do I protect personalized information, et cetera? So think about all those things as you start to build these applications. A lot of the connections you can make with the partners are done at a partner level. So for instance, if we're talking about an insurance company and we're trying to connect with a provider of leak detection devices, you'll have access to an awful lot of devices. You need to make sure that you figure out, how do I segment that I'm only getting from the users I expect? And if they have a multitude of devices, how am I only getting data from the devices that are related to the solution that I'm building, so that you're protecting the customer's privacy and information. Next thing on the agenda here would be the edge services, and you think about things like just DNS. So how do I get to the things within our solution that we build? Content delivery. So how do I get through firewalls? How do I load balance things for high availability, et cetera? So you want to start thinking about, does this particular application warrant eliminating a lot of single points of failure? Obviously, there's additional cost that goes with it, so you have to think about the value of the system you're building. But every solution you will build will have some level of these things in there. Next thing I have here is IoT Transformation and Connectivity, and this is basically taking how do I take that data that I'm bringing in, securely connect it so that I know it's not exposed to being hacked. It's got to be scalable messaging, so if I'm getting millions of messages a second, how am I going to deal with that? And how do I transform the messages, because they're going to come in a variety of formats, and I need to be able to normalize them so I can do some level of analytics. So all those things need to be scalable so that we don't take the solution and create bottlenecks. And I see we have a question in the chat, which I will get to as I hand off to Gopal. I will answer that question for you. Next component I have on here is the Enduser UI, and there's actually various UIs. So I'll probably have some level of Enduser UI. So if you think about, let's say, an appliance manufacturer, they may have a UI for their end user, the customer who actually buys the appliance. There'll be some level of admin UI, which would be somebody who's kind of managing the overall solution. And then you may have some levels of dashboards, which would be for people in the lines of business who want to understand how many of my users are connected and how are they using the devices and those kinds of things. How many people have errors or problems with their device kind of thing. So there'll be various levels of UI, and you need to think about that in the scale and in the sense of the different personas that you're building this for. The next component here is a device registry, and this is basically how you're going to understand which devices I talk to. And you also have to think about, how do I register them and deregister them. So think about a device that will have some level of life cycle, and at some point I may want to remove it, so you need to think about that as well. And you're going to be able to keep in touch with that, all the basic information about the device. So I understand what level, let's say, of firmware is it running, those kinds of things are all kept in the device registry. Moving on, we have device management, and this is like, as I was referring to before, I have to have a way to manage this device. So how do I keep it up to date, push new versions of firmware, et cetera, down to it? So think about that from day one. How do I deal with it? And I need to be able to also maybe quarantine a device, et cetera, if it's not behaving well. So it's all those kinds of things you want to start to think about as you go. Next on here we have the device identity service, and this is how I do it securely. So am I using different keys? Am I going to use some things that are burned into the chips at manufacture time? But one of the things you need to think about is how do I make sure that I'm securely talking to devices, and I know that the device that I'm talking to and getting data from is actually the device I want to talk to, that there's no spoofing going on. Moving forward, one of the other things that a lot of our customers are using, and I've seen across the board solutions, is API management. And this allows you to start to build some APIs to get access either to the data, to certain commands that they can start to monetize. So not only are you building the solution for their internal use, but how can they expose some of the aspects of whichever solution you're building to some of their partners and or customers that allows them to monetize that going forward. Application logic, this is basically what it says it is, and this is the core of what your application is. So now that I'm collecting data, what is it I want to do with it? Maybe in the case of those devices initially, some of that application logic may be registering the device in a warranty system, for instance, which would be interacting with something on the enterprise side. Other things that I might want to do could be that a customer wants to be able to order something through that device. So additional application capabilities that you have. In the case of a washing machine, they may want to be able to set a notification, for instance, that when the wash cycle is over, that it's going to notify me it's done. Or I want to be able to start the washer remotely. Next, we have analytics, and this is probably the most important part of the overall solution, and that is, why am I collecting all this data? Well, I want to be able to get something out of it. I want to be able to either get insights out of it. I want to be able to reduce my cost. It's all about starting to understand more about the device in the field as it's actually being used, and its current status and health. So this is probably the heart of any of the systems you're going to build. It's going to be analytics related, and that's where the value is going to be for the customer. Next, I have in here is a bubble for process management, and this is just being able to build structured workflows so that, for instance, a new device comes online. What are the things I need to do with it? Well, I need to see if a customer already exists. If they do, I want to attach this device to their account. If they don't, I need to be able to register them. And maybe I need to interact with other things on premise, be like I said before, the warranty system, etc., as an example. So I need to have some way of building a process flow as part of my solution. Next thing I have in here is device data store, and this is where I'm going to start to store the data as it's coming off the device, so the actual readings that are coming out, the metrics that come off. And one of the things that's probably important to think about here is, I know it's represented by a single box, but you may have to use multiple technologies in order to solve this problem. And it has to do with, what am I going to do with this data, maybe short term, what kind of reporting do I need to do, what kind of analytics do I need to do, and then how do I move it off to a more longer term storage that's more cost effective, depending on how long you want to keep the data. So in the case of the examples of what I'm building here at IBM, we have a 3-tiered storage. So it just depends, and it's all about whether what is the usage of that data? How do I make it the most cost effective for a customer? And that's, like I said, some of the things you need to think about in order to make it viable long term. Next thing we have on here is the enterprise layer of the transformation and connectivity, and this is because I need to interface with systems on premise. Again, I'm going to have, much like I have bringing in device data, I may be bringing in data from on-premise, so I need to have secure connectivity. I need to be able to transform data because it's probably not going to be in the format I'd like it to be in, and I need to have, obviously, connections to the data, and it needs to be specific. Most customers are not going to let you open up just big firewall holes. It's, how do I connect and say that I can only get to this particular database server, for instance? How do I start to do those kinds of things? Moving on, we have the enterprise user directory. This is typically some customer's LDAP server, and the reason why this is an important thing to consider is multiple users, everybody doesn't want to have 100 user IDs. So if I work for a particular company and you're building me a solution, and I've already got an ID and a password, and it's stored in my company's LDAP, hopefully you're going to tap into that as well, so that I can have that same user ID and password work for the system that you're building. This is something that is often not thought about up front, but as you start to build it out and you think about if on a grand scale, if I've got thousands of users, you don't want to have every one of them have to manage yet another account. So you need to think about how do I tap into a customer's already existing LDAP directory. Next we have in there is enterprise data, and this could be various different systems from, like I mentioned before, a warranty system, could be SAP, could be historical data that they have, it could be various things, but definitely you are not going to build everything that you need in the cloud. You're going to have some level of data that already exists in other systems that you need to inevitably interface with, connect with, maybe update as well. So you have to think about how do I make this a two-way street? How do I bring in data to do some of the analytics that I need to do, and at the same time be able to push data back down and update some systems based on what I see. And that could be things like an asset management system that I want to update it with different errors that I start to see in the field, different readings so that I understand how an asset is progressing, whether it's degrading, whether it's time for it to get service. So I might kick off a workflow and open up a ticket in an asset management system. So that would be a case of pushing bidirectional data. Moving forward, we have enterprise applications, and like I mentioned, this could be something like an SAP, could be a whole host of applications. And this is why it's important at this point, much like any other architecture, that you go through the use cases and understand their personas and what are you trying to do with the system and how do I integrate with various different systems that already exist, where the data exists for those, how do I get access to it, what are the security rules around those things, what are they going to let you update, and in some cases, even though you may be able to do bidirectional, the answer may be that all you can do is read from them. So all those things to think about when trying to meet a use case for a particular customer. And then moving forward, got identity and access management. Looking at the security side, you have to think about that in a horizontal way, and that when you think about security, it needs to span the whole gamut of the solution. So when you think about security, you can't think about it as, well, I need to worry about end user security or only about what's happening in the cloud. You need to think about how do I deal with security end to end and protect the data, protect the devices, etc., and be able to do it for the life cycle of a device. Last on the list here would be IoT governance, and again, this is important that you have a way, especially with any cloud application, of introducing new types of changes to the environment. I know it's very in vogue to talk about continuous delivery, and we do that as well. But again, we have a governance process so we understand with all the changes that are going to happen within a system like this, that everything has been tested and we're not going to introduce challenges and problems into the system as we go. So overall, if we look at what's in the middle here within the big gray box, that's what we call Platform-as-a-Service. That's typically what gets built and provided by an IoT solution itself, by the provider, whoever's out announcing whatever solution. And they typically include all of those different pieces. Even though they may get them from their cloud provider as different services, they're going to bundle these things together and offer it as a solution. And as I move forward, one of the things that's changed a lot in the last year is that platform providers are starting to provide these in groups of services. You've probably seen that Microsoft has made an announcement in the space, Amazon has made an announcement in the space, IBM has made an announcement in the space, where everybody is starting to say that, yes, you can still, as a developer, pick your individual parts, and some people will, But in other cases, they're saying, well, you as providers have some best practices based on your experience, and we'd like you to start to pull some of these parts together in a logical pattern for us and be able to manage that for us as a whole, as a unit, as opposed to the individual piece parts. So that's something that has evolved in the last year, and you'll probably see it continue to evolve as we move forward to getting to even a more hardened set of components within a solution. And a lot of this has to do with the maturity of the market around IoT in general, and that, you know, as patterns start to emerge in different industries, you'll start to see a lot of this get hardened. And moving forward, I think this is just a summary of all the components. So this is back to bringing everything back together. And I think if I turn to the next slide, I should be handing it to Gopal. So Gopal, if you're ready.
Sure.
Take
Thanks,
it away.
As Eric has gone through the reference architecture and all its component and subcomponent, now I will take you through an example, a smart home for insurance. And before I do that, I would like to share a story about a friend, actually, why this is important, you know, to have insurance company get into this IoT reference architecture kind of situation. So one of my friend, actually, a couple of years back, he has a 3-story house, and he was going on vacation, and he has no sensors for leakage or temperature sensors. And he went to Disney World for 3 weeks, and then this was the winter time, and there was a frozen pipe busted, and all his 3 floors got wet, and a lot of damage happened. When he came back, he found all this, and he was really struggled for like 6 months to get things fixed from the insurance company. And this can all be avoided if you are using the sensors and devices. And we are now using in our homes. People start using the various connected devices and sensors. So it makes sense to leverage that for the insurance companies, and that's what this example is about. So before I go into deep about this, so some of the advantage we should see. So what are the advantages? First advantage is insurance company can improve the services to their policyholders or homeowners in this case, and they can also provide the insight into any risk in their home, and this is the key point. Also, if damage happen as they figure out, they can be more proactive and then can assess the situation, like they can warn to even stop bigger damage. So a lot of possibilities are there. As I just shared the user story about the friend, all should have been avoided even in 1 week notice, in 1 hour notice. If not water leakage enough happened, they can send an alert on the cell phone. They can inform that you have some water leakage, and if they have an actuator to close the water flow, they can even activate that. Depends on how far you go, whether insurance company want to provide that facility, or you want to provide that some neighbor can come and stop the water flow from the front of the house. So all possibilities are there just with this kind of using the sensors and devices and connected with the insurance companies. Now, another thing I want to mention, so somebody asked a question, I will try to, when I am explaining this example, I will try to answer that also. That will help actually to get more clarity about this. But before I do that, another important thing I would like to mention that the device makers, right? So you buy the sensors, as Eric was mentioning. Not necessarily all the insurance companies, for example, need to provide the sensors, right? So if you are using any insurance company for your home protection, you might have already some of the devices and sensors deployed, and they may be from some other company. For example, you can go to Lowe's or Home Depot here in U.S. and buy the leakage sensor or water flow sensor or temperature or actuator to stop the water flow. So all those you can buy, but key thing is take a simple example for a bulb, IoT bulb if you buy, then you have to buy a hub, and that's what is kind of IoT gateway, where you connect that bulb through your local network in your house through that gateway. Same thing you do. So if you are using the gateway, basically you are using that device maker cloud actually, and I will go on the next slide and talk about that. But this is one thing I want to mention, that this reference architecture you can use for connected cars, smart home appliances, smart home insurance, and any other use case. And this is why this is the high-level cloud customer reference architecture for IoT. Next slide, please. Thank you. One slide back. Okay. So this is the architecture. We have used some numbers here, and some components are grayed out. Just for the clarity, we have done that so we can show the numbers more clearly. So I will walk through the numbers to talk about how this reference architecture components are used here for implementing the smart home insurance. So we will start the number 1. So first thing, as we were mentioning earlier, you need to deploy the sensor. For example, in this case, we will take water leakage, water flow, temperature sensor, and actuator to stop the water flow while using a valve. So those are the sensors you will purchase. Just you can have other sensors also in a smart home. For example, you might be using video surveillance, or you might be using smoke detector, or any other kind of sensor. But I will stay with the water leakage situation to explain this. So that's the first thing you do. You purchase the sensors or actuators and deploy inside your home. Second, you need to have the smartphone where you will download the application or app from the insurance company, and you will log into that insurance app, and then you authorize insurance service to access the device data. Whenever the leakage is happening, the number 1, the device, IoT gateway, and peer cloud. This is peer cloud. In this case, is the device maker cloud. So those 3 actually are always there in your house once you purchase the sensor or actuator and deploy it in your house. So number 2, you need to log in and authorize insurance service to access the device data. And you see the number 2 on the right side also. So insurance policy will be there in their enterprise data, and that's what that number 2 is, to access the insurance policy data and how you can do the authorization to the insurance service. So that's why number 2 is on the left side as well as on the right side in the enterprise data for the insurance company enterprise network. Number 3, actually, this is where your application logic, by using that, you map the user, device, and insurance policy within your cloud service. So as Eric mentioned, the middle, the provider cloud is the one, that's where your insurance service is running, and application logic will do the mapping to user, device, and insurance policy. Once you have this mapping or linkage established, then you will do the data mapping, which is actually in your device registry. Will have the information about your device. You will have the device data store, and once you have this data mapping done, then you will have this data available. Now you will start pulling the data with a frequency, and you can decide that frequency depends on weather or other situation. So that's why when you are pulling the data, you can also leverage other services, which is number 5 is in the analytics part, where you can analyze the other service and change the frequency or the application logic, like you want to pull the data every 5 minutes because temperature is dropping seriously, and or you want to even have every minute. Depends on the situation. You can pull the data with that frequency. So for example, some water leakage is detected, right? So you will have the first occurrence there, and then you can analyze that, oh, there's some moisture or one drop of water leaked, and then you can find out, is it leaking every 5 minutes, every hour, or how much is the frequency, and based on that, that analytics will run and find out, whether alert need to be sent, and that's what that number 6 is on the left side to the end user application, and right side to the insurance company enterprise application. That there is a water leakage started, and insurance company can also send notification to the end user application on the left hand side, and they can take the action as I mentioned. They can shut off the water via the actuator valve remotely, or if a homeowner is there inside the house, he can go and assess the situation. And this water leakage can be anywhere, under your sink or near washer dryer or any other place, or depends on the weather. It's a freezing weather and pipe busted, they can figure out that also based on how many sensors they have and devices they have used. So once this situation is happening, and then there is a threshold that how much water leakage is occurring, and based on the frequency of that, they can find out, okay, this is enough water leakage was not stopped because of the water shut off by the actuator or valve by the user, and then insurance company can determine, oh, there is damage happening and a homeowner did not take action. So they can then, based on this, they can start the claim process. And that's what the process for the claim is there. But all this can be avoided at number 5 itself when they send the net notification at 6, and that situation will not occur. But 7 is for the workflow process in case if claim need to start, initiated on that damage, and then they can also choose, if they want, they can use the number 7 process in the cloud or enterprise network itself. But that's what that number 7 we showed, that they can leverage the process management in cloud to process the claim. So with that, actually, I will add a few things for the advantage why we are doing this with the cloud. So with the cloud, there are several advantages. So first, I will talk about with the cloud, you can use the scalability and elasticity and volume of data with velocity. So that's the key thing. And then if you are having the more load, or you need to add more resources, this can be done easily in the cloud. And that's what is another benefit. Another thing I will mention, it's very easy to do the implementation as well as maintain if you are using this kind of architecture over the cloud. The steps, next slide, please. The steps I talked about already, but here are the detail of those 7 steps on which we went over on the previous slide. Now I will, next slide, please. So this is the slide, once you have this architecture, somebody can say how I will use the open source. So we have tried an attempt to show this in little detail, like especially for the provider cloud and some of the enterprise network. So I will start going through this list, actually starting from the left side with some of the protocol for the IoT gateway. So MQTT is very popular. We have WebSockets also. We showed the HTTP 1.1, but MQTT will be the preferred one, as well as CoAP is there, which is Constrained Application Protocol. So these are some of the protocol for the IoT gateway we suggested, how you will come inside the provider cloud via the public network there. Starting from there to the next one is the S service. So for CDN, which is the Content Distributed Network, Apache Web Server, OpenStack, object storage. These are some of the examples, but this is not like limited. There are more companies for doing the open source for the CDN, and so does for the other like load balancer and all, but we listed only few of them. Going to the clockwise there, device management, WSO2, Ka and Kura, and Device Hive. These are some of the open sources which can also be used for the device registry. Next is the transformation and connectivity. This is what Eric mentioned, how you will use the transformation connectivity to go and access the enterprise network. So you have active MQ, TYK, and MovieSense. I will move to the right toward the enterprise network before come back to the middle part again. So for enterprise user directory, Open LDAP is a very good choice, as well as OpenStack and Keystone. So these are some of the open sources for doing the LDAP kind of enterprise user directory for authentication, etc. Next one is the enterprise data. So we choose some of them like MongoDB, CouchDB, MySQL, Postgres, and Hadoop for a big data kind of situation. But this list can be very exhaustive, but these are just some of the attempts. Back to the provider cloud area. So I will start there with the API management. We have WSO2 API Manager, TYK, and MuleSoft. These are some of the ones for the API management, which will help with the API. Basically, API management, as Eric mentioned, some of the third-party services you can leverage from here. Next is the application logic. So Node.js is the very popular choice as an open source. Next is device data store, MongoDB. This is similar to what we have in enterprise data, but listed CouchDB, Hadoop, object storage, and PostgreSQL. Process management activity is a good choice. There is a process maker and JBPM. Actually, some of them we have listed on the same line because of the space issue, but JBPM and process maker are different open sources for the process management. Coming to the next to that is analytics, which is very important. And Eric talked about the subcomponent. So if you see the Apache Storm in the bottom there, that's for the streaming kind of thing. And you have Apache Hadoop, Spark, and Bird. Those are the open sources can be used for this analytics subcomponents. IoT transformation and connectivity, Active MQ, TYK, MovieSense, and OpenRefine. These are some of the IoT transformation and connectivity open sources we recommend. Last there is visualization. So data wrapper, D3, Angular, Chart.js, Lumify, and Freeboard. These are some of the ones can be used for dashboard reporting and visualization. And last one there is Cloud Foundry and OpenShift for the PlatformasAService, very commonly used open sources. So those are the some open sources we recommended for addressing components and subcomponents. And but we can also suggest this can be used in combination with other companies who provide because open sources you may not have the support and maintenance as you need it. So depends on which one you use, like IBM or AWS or Microsoft, Google. But you can mix and match also, because you might have certain components in the enterprise network already working as your legacy application, and you want to choose certain components here, so you can mix and match. Depends on the situation and resources available. So with that, next slide, please. So Tracy, you want to cover that one? And then we can talk over the questions.
Thank you, Gopal, and thank you, Eric. Yeah, just really quick, to those on the call, we welcome you, if you enjoyed this presentation, If you're interested in other architectures and our respective webinars with the authors, you're very welcome to join the Cloud Standards Customer Council. It's a free membership. There's a link right on this slide. By doing so, you're also welcome to become a contributing author. We have a few different topical working groups. There's a security group, a big data group, VAS, and then a practical guide to cloud computing working group. We publish about 10 to 12 papers per year. So we'd love to have you in our network if this is of interest to you. We work with standards bodies, open source groups, and then our entire membership, which is predominantly cloud customer type organizations. There's close to 700 companies at this point. So just opening that invitation to you. And also here at the bottom of the slide, there's a link to our resource hub. This is where all of our papers are made publicly available for download. So now we do have some questions that came in. And now is also a great time if you have any other questions you want to submit into the questions box. The first question here goes back to Eric's review of the architecture, asking if we could provide some examples of IoT gateways.
Okay, so there are the traditional gateway players like Cisco has several models of gateways. Dell makes some gateways. You could actually use a Raspberry Pi as a gateway, so for low-cost solutions. So there are various ones for different flavors. Depends on the environment you want to put it in, like I mentioned before, and how much processing power you need to do at the edge around analytics. So they come. Those are examples, and they differentiate based on, like I said, the environment you want to put them in, how fast, what kind of network traffic you want to push through them as well. If you think about it at home, from that perspective, if you've been to Home Depot and seen Wink, they make a home hub that translates some of these things, as does Samsung. So there are various other ones as well in that same space.
Great. Thanks, Eric.
Yep.
Next question. Going back to the smart home example, how can water leaks be detected by water companies? How do they differentiate versus real water usage?
So, I think in the example that Gopal was talking about, it's more being detected by you, the homeowner, in conjunction with your insurance company. But the water company could do it by looking for anomalies in usage patterns. What they can't tell, because they're only seeing it at a macro level, your usage at the house, is the difference between a leak that's happened where a hose broke, let's say, that connects to your toilet, so it's spewing water all over your floor, or you left your hose on outside and it broke and you're just leaking water outside, which is causing water usage, but it's really not creating too much damage as opposed to the indoor leak. So yes, they can look for anomalies in pattern usage, and that would be something the water company can see, but the deployment of the sensors is more to localize and understand where is the leak and what are the potential challenges that happen with it.
Yeah, so Eric, I will just add to that. Water companies, you already covered, but water company cover only, at least in North Carolina, where I am in the U.S., they have like, if it's inside your building, and from building to even to the meter, and they have like water meter. And I think they cover like 2-3 feet if pipe is rotten there. After that, homeowner is supposed to cover. So water company only cover if it is near their meter, 1 meter or 1 or 2 feet pipe was broken or before the meter, not after that. So liability is another, but depends on where you live. But water company can also start using some of this technology, and that might be useful for them. But our example covered on inside the home, but not limited. Do you want to talk about, Eric, other, or maybe I will take a shot or pros and cons of the protocol. I'll just talk about the MQTT versus the CoAP, which is Constrained Application Protocol. So, like both of them are open standard, and, like, of course, run on IP, have a range of implementation, but key thing is MQTT gives flexibility in communication pattern and act purely as a pipe for binary data, but CoAP is designed for interoperability with the web. Like it's more for like also machine-to-machine applications, such kind of a smart energy or building automation. So I will use carefully, like which one you want to use depend on the use case.
Yep, and the other thing to think about with MQTT is it's a pub-sub model, so that I don't have to establish a bunch of point-to-point connections. It's I publish to a bus, and all the subscribers who are looking to do something with that data or know about it can just subscribe to it. So it's much more scalable from that perspective. The last one we have up here that's in the chat is, can we place fog computing in the presented schema, or schemes, sorry. If yes, where can it be placed? And that would be, the fog would be the gateways. That's what I would consider the gateway. So it could be a layer of gateways if you want to consider edge fog cloud. You may have a gateway that actually talks directly to the device. If you went one layer up where you had gateways talking to a fog node to do some level of processing at that level. And the reason why you would do these different things is you want to be able to do analytics at the level that is where you have the context to do it. So if I use an example of a manufacturing plant, for instance, if I want to do analytics at the level of the line itself, let's say where they're welding or painting or whatever, I would consider that edge. If I want to do analytics at the factory level where I want to understand some things about the whole car as it gets processed through the factory, that you might consider fog. And if I want to look at across factories, I would do those kinds of things in the cloud, because I obviously wouldn't have all the knowledge I need at one factory in order to see across. So that's where I would place, edge, fog, and cloud.
Want to add on that, Eric? In paper, we did write a little bit about the edge computing, fog computing. So please go through that. In the proximity network area, we have written some description about the fog computing, edge computing. Paper has a lot more details to go over the details we have covered here.
Do we have time for one more question?
We do.
Paul?
Absolutely.
Kind of a overarching. How do you see this coming together down the road? Macro delivery, or has it reached its peak?
I think it's going to continue to evolve. I've been working with IoT before it was called IoT. And originally, and even when IoT itself became an in vogue term, things were all about individual microservices and go build your own, roll your own kind of solutions. And we've seen the first turn of the crank, like I had mentioned, about the three major players have put things out that are now there's more of a grouping of services, and they're more at a generic level. I think what you'll see over the next year to 3 years is, as these patterns become more well-known in certain industries, that you'll start to see them actually harden up, and there'll be more of a platform that gets delivered for that industry. And even the base platform across industries will start to get hardened, so that there'll be more services that come out of the box as part of a platform as opposed to the individual services, all in an effort to make it easier for you to build the solutions on top, as well as price things for the end customer.
So, Paul, I didn't know if you had any additions.
I think Eric covered pretty good. No, Eric did a good job.
Okay. Great. Well, looks like we can give folks a couple minutes back. No more questions. Thank you. Thank you, Eric. Thank you, Gopal. And thank you for everyone that was able to join us today. In just a moment, this presentation will be archived and available to view on demand. So you're welcome to watch the replay and share it with others that might be interested in the topic. And here on this slide as well, you're welcome to follow us too on social channels, where we will post sort of the on-demand resources from today as well. So everyone have a great rest of the day, and thank you again. Bye-bye.
Thank you, Tracy.
Thank you, Tracy.